Hey folks, hope you are doing well. Um, Today's tutorial is about how we can do partitioning in Postgres with with zero to minimal downtime. So the folks who doesn't know about partitioning, basically partitioning is a way of you can say that we have a big table now as the as our as our company grows, the data stored in that table also grows. So we need a way to manage that data. So what happens is that, let's say if we have a table called as orders table, right? So and we are running our app for quite a few years now, so it has like 2-3 years data. Now the single table is being used to serve all the queries, which is like which over the time causes different issues, like query time will increase, the vacuuming process also get increases. So to counter, basically to handle those issues, we what we do is there is a process called as partitioning, where we instead of storing the data in the one single big table, we store it in the multiple partition, which is basically like a child table. So I will draw a diagram to help you understand on how the partitioning works and what is partitioning actually. And in this tutorial, we will be covering only range partitioning, and mostly touching on how we can do it with zero to minimal downtime, right? Because in the production system where there is a lot much traffic, we can't say that we want to take downtime for like a day or something to just do the partitioning stuff. So uh, okay, let's start. So as I was saying that what is partitioning, right? So let's suppose you run a company of apparel, basically selling merchandise, selling clothings and all those things. So you have to maintain an order table, right? Orders table. Now what does this order table contain? It can contain anything from a primary key, which is an ID, uh, item ID, and something. It also we generally store created at as well, which is like when this order was created, right? So these all things we store in the order table, right? So what happens is, over the time when again I am repeating this, that over the time when our usage of our app increases, the data stored in this single table also increases, which causes the bottleneck or performance issue with related to vacuuming, with related to the query being slow. Now what is partitioning is that when we instead of keeping all this data in a single table, what we will do is that we have the multiple tables. You can call this as a child partition. Let's say this is called as a let's say these are a child partition and this is the parent partition. Okay, you can consider this as order partition. Table name is ordered partition. I'm just for right now, just for explaining purpose, I'm giving it some arbitrary names. So what happens is, I'm saying that I will store my August 2020, or you can say July 2025 data in this table, August in this table, September in this table, and then October in this table. Similarly, the forward and backward partition will go like June has a different partition, and November 2025 has a different partition. So, and all these child partition are basically these are the child of old partition table. So now what is happening here, right? So if you consider this table versus these four partitions, now this is a single table where you are running where all the queries are being hit the same underlying database, same underlying table. so it will also result in query slow, because you have to scan a lot of records, and even the index size is also increased, right? Because you have all the data is present in single table, so size of index is also large. Vacuuming will also take time, because the more the data is, the vacuuming will also, like, it will slowly takes vacuuming takes some time basic to run. So instead of this, what is the benefit here in this thing is that we have basically segregated the data based on the month when we receive the order. So now July will have a single table. These are underlying table itself. So in partition, what happens is data is no data is stored here. All the data is stored in child partition itself. So July data is here, August data is here, September data is here, and October data is here. So now it enables us to run the query faster, because if I have to run for the July data, I can run only in this table. These three tables are not impacted. And similarly, if I have to run any other month data, I can run it here itself. Now, so this is, I have mostly talked about the range based partitioning, but there are other methods of partitioning like hash partitioning and list partitioning, which I'm not covering here. But to give you an understanding of what hash partitioning is, that you have a predetermined hash, you have number of fixed partitions, like let's say 3 partitions, and you write a hash function which tells you where that record will go. Either will go to first partition or the second or the third partition based on the number of partition you have. Similarly, list partition is like, you can think of list as, let's say you want to record the rainfall in 5 top cities of your country. So you create each partition for each of the cities, and so that particular partition will store only that city record. So this is also a list partition. What is range partition is that when you are basically creating partition over a range. So I am saying that I am creating a partition from July, August, September, October, which is a timestamp also, which is also timestamp based partitioning generally. So by the way, not always it's a timestamp, but range is like, which is an you can consider as 1, 2, 3, 4 is also a range, right? So what I mean by timestamp based partitioning is that you are storing it in a particular range. So you are saying that the July data for July range is stored in this partition, August is stored in this partition, September is this partition. Generally, range based partitioning is associated with timestamp only. So this is about partitioning, right? Now we should first arrive also, like, one benefit of partitioning we observed here is that it makes our query faster, but that does not happen magically. I will talk about how it happens and what we have to do to actually basically benefit from the partitioning. But the second, also most important thing with benefit of partitioning is archival. So what is archival? Archival is like when you are so at a point in time, right? You don't require all the data in your live database. So what I mean by that, let's say if we are in 2025 and our app has launched in 2020. We generally don't require we only require last 6 months of data. Require last 6 or 1 year of data. So this doesn't mean that we are deleting the data. What does it mean is that we are just in the live database. We are only storing the last 6 months or 1 year of data. So what is the benefit of this, right? So everything, whenever we run, there is a cost associated with the things, right? So if we are storing more data in our live database, it is incurring us the more cost. But if we are only storing like recent database, like 6 months or 1 year, the storage cost also decreases. So it is one of the other benefit that we can do. Like when we do with the range based partitioning, what we can do is, let's say if I am only storing last 3 months of data, hypothetically. So I need these three datas, right? Or let's say these three data. So before July 2025, I can archive that data and move it to cold storage, or maybe S3, move it to cold storage like S3. So which will help in reducing the database storage cost, right? So now we understood what is partitioning, why we partition, and what are the advantages of partitioning apart from only just query making it making queries faster and vacuuming process. Now what happens is, right, we can go ahead whenever. Now let's talk about one thing, right? So we are now know why we want to do partitioning, but now we will talk about how to do partitioning. So how to do partitioning. Now doing partitioning for a project which is starting from scratch is easier, right? Because why it is easier? Because you can by default create all the tables as a partition table. We don't have to do anything extra here. We just have to definitely think about it, but we don't have to do any other pre-processing to basically move to partitioning, right? We can directly start with the partition table and we are good to go ahead with it. So, but what about the old projects? So this is a tricky part, right? So this part is like a little tricky, this one. Tricky part. Why I am saying it's a tricky part is, like, if you think about your existing database, right, which is basically storing in the live production system, it is we are constantly doing writes and reads in that database. So to do the partitioning, we have to either take the downtime or we have to do some mechanism to basically move to from the non-partition table to a partition table. So that's why it's a tricky part, because we can't like generally in most of the cases, like we can't take a longer downtimes. When I say longer downtimes, like a day or two or something like that. Even like 4 hours is a longer downtime if we think about it. So but before diving into that, let's talk about like what is the way that we can move from non-partition to partition. So non-partition table to partition table. How? Right? So we have different strategy. Let's say strategy strategy 1. Let's talk about strategy 1. Let's say there is an order table again. I'm considering as order table. Order table. It has for now I am ID. I am creating ID. I am creating created at, and I am creating, let's say, name or something, or I don't know. Like we can say customer name instead of ID. But customer name can be same, so we can say item ID, right? Now created at would be ever increasing, right? Because it's a timestamp based thing. So what we decided is we will do the range based partitioning based on created at. So goal here is range based partitioning using created at. Okay, now what is the way we can do, right? This is strategy 1. I'm not considering here whether I'm taking basically I have to take downtime. So strategy 1, like what is it's a simple strategy. What I will do is I will create another table called as order new, right? I will create, this is a step 1 of this order new, have order partition. Let's call this as order partition, right? And Let me write it in this way, it would be much more better. So first step is to create new table, order partition. Once that table is created, copy everything from order to order partition. So this order partition is already partitioned by created at. Now we don't have to necessarily, once for these two steps, we don't have to necessarily stop our system, right? We can parallelly copy everything, but once our order partition catches to the order table, basically we have almost copied everything. Then to copy the diff, basically we have to store our live traffic so that it don't keep on inserting the record in order table. And what we will do is we take the downtime here, copy everything that is there to left, copy the diff, basically copy the diff. Then what is the fifth step is rename order to order sold, and the next step is rename orders partition to orders table, right? Order, or you can say order, or whatever the table this is. Let's say order. So if we think about this step, let's talk first about fifth and sixth step. Why we did this is that we don't want to change the code to start referring the orders as order partition table in the code base. What we want is we want to use the same namespace for table, that is order. So what we did is we renamed the old table to order old, and then we renamed the order partition, which is our newly created table in the step 1, to order table. So using this, what will happen is that we will start using the partition table, and we will our tables is now partitioned. But what is the problem with this thing, right? Let's talk about the problems with this approach. See, it's easier. It sounds easier to copy when we say step 2, like copy everything from old order to order partition table, right? But it is actually difficult. Step number 2, it takes huge amount of time and resource to copy the very huge table to another table, right? So what will happen is that when I say very huge table, I have an experience of working on like a table which is like 5 or 6 terabyte of data, and we have to partition that table. So when we initially went ahead with the strategy 1, right, it is like basically we tested this in the snapshot of the existing running database. It takes a longer time, like it takes like even 2-3 days to just copy it, so which is a very huge amount of time. And even to do that, so we were doing it by in some we have to increase the db size as well, to so that it basically have the more resources to do this operation. So that's my take, like it is a very resource intensive operation, this operation number 2. And the third is like we don't know how, like downtime, basically the step 4, we have to catch up, basically copy the diff. Generally this won't take much time, but there is certain time attached to it, right? We are like, even let's say there are our order partition is running like 1 lakh row behind order table, so we have to catch up that 1 lakh record in that particular downtime window that we have taken. So definitely, so there is a certain time that will be required for this operation. So this is in strategy 1. So it is not we can't do this. We definitely can do this when there is a smaller database or something, but generally for a huge table, it is like not a very effective strategy to go ahead with. So there is an what to do now, right? So we have to follow strategy 2. Strategy 2. Now strategy 2, what it says is that in a strategy 1 we completely deleted or trunk this order table once we switched to order partition table, right? Basically after renaming it. But what does strategy 2 says is that instead of deleting this table, right, and instead of copying everything, attach that old table, basically the existing table that we have right now, non-partition existing table, as a partition, as a child partition to the partition table. Okay. So what I mean by that is that, let's say this is our order table right now. Order table. And I'm saying this is non-partitioned. Okay. I'm creating another table, which is, again, you can say order partition, partition. Now what will this strategy is saying is, instead of copying the thing, attach this as a child partition of this parent table, right? Now this is the thing I'm doing, right? I'm attaching this. After this we will create our other partition. Let's suppose this contain the data from, I would say, minus infinity to let's say 30th of September. If I want to say that I want to use this partition for 30th of September, and after October I will use this partition, Oct 2025, and November 2025, and December 2025, December 2025, right? So this is the strategy 2. So once we reach the retention period is mean like how much backdated data we want to store. We can directly go ahead and detach this table, and then we have this partition itself, which is following that 1 month data 1 month data storage. Basically October has October data, November has November data. So what is the benefit of this storage, right? We are not copying anything. It will save resources. It will save resources. There is no diff we have to check for, because once we take the downtime, there is no new records being inserted or updated in order table. We can directly attach this as an order partition table. So this is the strategy that is actually very helpful when we want to do the partitioning. But what happens is that this is not, again, as I said, right, initially it's a tricky part. So it's not like you can directly go ahead and attach this table as a child table of this table or order partition table. So there are few things that we have to do to ensure there is no downtime or there is no issue in that. So I will walk, or basically tell you the pitfall, if also that from my personal experience that I have faced, so that whenever you do the partitioning, you might you don't face that issues. So let me write what needs to be done. So what do we have to do, right? Whenever we are in partition table, as I said, so there is a concept in partition table, all the data is stored in the child table, right? So order table would have its own data. October data is stored in this table, November is here, and December is here. So older partition doesn't store anything, and even the primary keys are in the child table itself, right? So we need, whenever I am saying, let's say in non-partitioned case, NP case, if I am saying ID is primary key, right? Basically, let's consider the table column as id comma item id comma created at. If I'm saying id is primary key, then the same id can't be in the table because Postgres is handling that constraint, right? It's a primary key, so you can't have the basically duplicate primary key in the same table. But as I said, in the partition case, what happens is if I have October 2025 partition, if I can have ID1 here and I can have ID1 also here, because these constraints which are there is guarantee is basically applied in the child table. So October 2025 doesn't know that there is already a ID1 in November 2025, or same as November 2025 doesn't know there is a ID1 in the October 2025. So how do we guarantee how to guarantee uniqueness? In partition table. So to guarantee the uniqueness, we have to take primary key plus created at, or basically you can say partitioning key. Partitioning key is nothing but the key or the column with which you are partitioning. For our use case, we are using created at, so it will give us id plus created at as a primary key of the table. So now I can't have this thing, right? October you can consider 01 10 2025 2025. This case is not possible, right? Because Postgres will itself not route the October record in the November partition. So whenever the October record will be routed to October partition, it will check whether it will anyway able to check the uniqueness, and since it's already there, it will reject that particular entry. So that's how the uniqueness is, or basically the primary key is also attached, and that's how it guarantees the uniqueness. So why I'm telling you about this is that since we are attaching the old partition, there are some pre-processing step we have to do, right? We have to create a index, or basically we have to create a unique index beforehand in this table, so right now with current scenario, let's talk about current scenario, or we can say now in current situation, primary key of order table is id, right? But as I said that we also require created at as a primary key. What we will do is we create a unique constraint in order table with id comma created at. Let's write this block as pre-processing, or we can say commands to run before partitioning. This is not doing on, or let's say partitioning, we can say we are doing partitioning of table on T day, partitioning of table on T day. So we can say command to run on table before T minus 1, before any day less than T. Basically we are running this before partitioning day, right? So what is the first command is that we are creating a unique constraint, creating unique index, basically index, we are creating unique index, basically a constraint also on order table. We can say this as we can say order ID created at unique on order ID comma created at. Okay, so if you see this thing, right, so this is running any day which is before the partitioning day. So right now all the queries are being served from non-partition order table. So we are running this query, but if you run directly this query it's a blocking query. So to not run to basically we to ensure that this query does not run in a blocking way, what we will do is we will run concurrently. We will run it using concurrently, right? So now it won't blocks the write. So earlier if we run without concurrently, it will block the write. It will take the log and it will block the write. So with running it concurrently, it won't block the table. So but what is the issue, right? There is one issue we have found with this thing, right? Whenever we run something concurrently, it might or might not create an index. So this issue we have encountered that when we ran it at the time, basically on the T day, when we were trying to attach this order table to the order partition table, it says that the order ID created at unique is not a valid index. So this is also a case that we have to check. So whenever we run this query concurrently and when the query finishes, what we have to do is ensure this is a valid index. How do we ensure a valid index? So we can run this query, select pg class from pg index, where pg index dot in valid equals to false, and pg index dot index equals to pg class dot oid. I think I might but please do check. But major point to highlight here is very important to check, very important. So if what happens is, right, generally index take quite some amount of time in the bigger tables. So if this is not a valid index, then we can't do the partitioning on that T day itself. We have to shift our downtime day to some other day and do the partitioning once the valid index is there. So what I would suggest is, like, whenever we run this concurrently query, please ensure before this T days that the index is actually a valid index that we created. If it is not valid, it will show up in this query. So if it is not valid, then we have to rerun this query again, and then again check whether the index is valid or not. Now this is one command, right? Let's say command 1. Now let's talk about another command that we have to run. So what happens, right? But in behind the scene, what happens? Let me come here. Behind the scenes of attaching a partition in a table. So what happens whenever we attach a partition in a table, right? Postgres check whether the constraints are followed. What does it mean, right? So let's say if I'm saying alter table order partition attach order, where created at is I hope I'm running the right command. Let me ensure. Oh, sorry. Attach order for values from let's say I'm saying infinity to minus 30th September. Let's say instead of infinity, I can say any time which is before our app launch date. We can say 01, right? Or it's better I say 01 2020. Okay, now for values 01, 01, 2020, 2020 to let's say 30th 11 2025. When we fire this query, what happens behind the scene is that Postgres alter command always take access exclusive lock, right? So what does it lock means is that all the write operation will be blocked, so we can't do any new writes in the table. So so whenever we run this query, what does this for value for this for 01/01/2020 to 30/11/2025, what does it do is Postgres run a sequential scan on all the records of that order table. So what does the sequential scan does? It validates whether the record, basically the created at, falls in that time range or not. Because we are saying that we are attaching this order table in the order partition table by saying that it contains value from 1st January 2020 to 30th September 2025. So to guarantee basically this is being followed, Postgres does a sequential scan. So now think of this scenario, right? If there are billions of record in that particular order table, so sequential scan will take a huge amount of time. So billion of record in order table, sequential scan will take huge amount of time. Let me write these steps as at alter table, behind the scenes doing taking access exclusive lock and doing sequential scan on order table for the date range check, or the range check you can say. So if I have taken a downtime of 30 minutes, right, to do this operation, though then definitely a sequential scan on the billion of records won't be able to basically we can't able to run sequential scan at that time basically in 30 minutes interval. So this is increasing our downtime window, which we don't want. So what is the second optimization or second command we run before that is, so as I said, what is happening, right? Doing sequential scan on order table for the range check. So what we can do anyway, this range check we can do outside of we can do in basically any day before T day. So how to do is that we write this query alter table order add constraint constraint on, let's say constraint name is skip range check, which is checking a constraint created at is 2020 01 2020 and created at is less than 30 09 2025 we can check inclusive exclusive or wherever it is. So if you see this query, right, again it is running an alter command on the order table. So definitely it's a blocking command again, because it will take access exclusive lock to validate the constraint that we are adding, which is skip range check, is basically meeting this value or not. So what we do is that instead of asking the Postgres to validate this constraint whenever we are running this query, we say that let's skip that and validate only for the newer record that it is adding. So we add this not valid in this query. So what will happen is that the older records are not validated, but new record will definitely be validated, new record which is being inserted. Now we also have to validate this old record, right? Because we don't want this validation to happen on T day when the Postgres have to do when we attach this as a partition. So what we do is we do alter table order, validate constraint, skip range check. Now what happened in this case? So as I now you will this is the command to validate the constraint, but it will come to mind that again we are running an alter table command, so it will take access exclusive log, which is again a blocking log. But this is not the case. When we run this command, what happens is that it runs in a when we run this command, it basically don't block the table. It basically takes a share update exclusive log, which is share log taken, which is share update exclusive, which is similar to auto vacuum. So whenever the auto vacuum is run, it also take a share update exclusive logs. So it is not a write blocking log. So our writes is also working. Parallelly, we are also validating the constraint. Now we also have to ensure that this command is run before T day itself. Now 1 and 2 steps are done. When we are on the T day, basically when we are on the partitioning day, what we have to do is, now we will talk about that. So let's talk about that on T day. On T day, we create a partition table order partition, add primary key id comma created at. Right now, once the table is created, we add any other indexes that are there, add other indexes that we need, which were present in order table, Now what we will do is rename order table to order old, rename order to order partition to order. Now if you remember, we created a unique constraint here, right? This one concurrently. So this unique index, now we have to promote it as a primary key. So what we have to do is drop existing primary key from order old table, alter add created, add slash promote as new primary key of order old table, and then we will do alter table order attach partition order old for values 01, 01, 20, 20, 2, 30, 09, 2025. Yeah, that's it. So, and this in the should happen in same transaction block. Now what will happen is that when we run this command, right, since we already have done validated the constraint that the older value contain data from 1st January 2020 to 30th November 2025. So Postgres does not run the additional sequential scan while attaching this table to the partition table. So this is like, it will take once we have a valid constraint already there, it will take less 1 second or 2 seconds, and this whole entire operation generally takes that much amount of time, like 1 second or 2 seconds. So after this we will have order table as partition table. partition table, right? So, and the partition structure would something look like this. This is order table, and this is order old. Then to create new partition, right now I'm not talking how to create new partition, but generally you can create it manually or you can use pgpartment for that. So you can say this is October 2025, November 2025, December 2025. So these are the child partition. So the decision here is that we have taken a conscious decision here that we will still use the older partition for the any data which is before October 2025. So this is the conscious decision we have taken, that for any data which is before October 2025, we will query order old partition, and for other data we will query these partitions for which month that data belongs to. Now this cover entire partitioning exercise that we can do with minimal to zero to minimal downtime. But I will add, I'm not covering here how we can manage or create new partition using pgpartment, but I will cover one simple aspect like how to get benefits of partitioning. So as I said before, before starting the partitioning, right, it does not magically makes our query faster. So if we keep on running this query, select star from order where item where we can say, let's say some other value, let's say id equals to 2020 something, whatever it is. If we do this right, what it will do is it will do scan on all the queries, scan on all the partitions, because it does not know which partition to query. So then we have to get an actual benefit, we have to specify which where does this id present, right? So we can do select star from order where id equals to 2020 and created at is something greater than equals to 01, or you can say 10/10/2025, and created at is less than 20/10/2025. Now this is just a general query for understanding purpose that I have written. So now when this query will be fired, Postgres will route it to the October partition, because we have specified that it created at is greater than 10th of October to and less than 20th of October. So it will route to the October partition and then search for ID 2020. So this is called partition pruning, where we are not scanning all the partition for the data that we want to get, but we are only targeting a particular partition where we know that the data will reside. Yeah, definitely for certain cases we might not know where the data actually reside. So for that case we have to scan, but the good idea is that we find that's a business logic which enable us to do this partition pruning. So this is all about how all partition and how we can do it in zero downtime or minimal downtime. If you guys have any question, please post it in the comment, and please do like, share or subscribe. Thank you.